Hi everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. Vampire Survivors boasts a wide variety of weapons for the player to choose from, each one possessing their own unique abilities. And similarly, the game also has many different types of enemies. So in part 3 of this series, I thought it would be a good idea to combine the two together within a single part. We will be taking a look at how to create a projectile and melee weapon, and also some basic enemy AI. And by the end of this part, you should have a projectile weapon, melee weapon, and some basic enemy AI that follows your player around. Before we begin, there's one thing that we forgot to do in the previous part, and that is adding colliders to our prop prefabs. So head on over to our props folder, and in here, let's select which of these props need colliders. I recommend picking the props that you think need the colliders on. For instance, like this rock here needs the collider because, well, it's a rock. And these leaves probably do not need it because you just let the player just walk past them. Okay, and now that that is done, without further ado, let's begin. Let's start off with creating our first projectile weapon. For our first projectile weapon, we will be trying to replicate the knife from Vampire Survivors that flies in the direction the player faces. It is the default weapon for Gennaro. So download the Pixel Armory sprite sheet that I found on opengameart.org. You can find the link to that in the description below. It provides a wide assortment of weapons and armors to choose from, so you can spice up your game later on with many different weapons. And yeah, so let's drag and drop it into the art folder and rename it to weapon spreadsheet. By now, you should already be very familiar with the process, but make sure to slice the sheet by using the automatic preset and set the pixels per unit to 32 by 32. Drag and drop weapon sprite underscore 20 into the scene view and reset its transform. You can use any form of like knife sprite, as you can see here, that looks remotely similar to this sprite inside the sprite sheet itself. But for me, I'll just use this. So this is the sprite that we're going to be using for our first projectile weapon. The weapon will just basically be a knife that shoots forward and damages enemies. It is the exact same knife as in Vampire Survivors. So let's create a new subfolder under prefabs and name it weapons. Afterwards, rename the sprite in the scene to be knife weapon and move it into the folder to make it a prefab. You can delete the existing knife in the scene now as we don't need it. So the reason this sprite has to be a prefab is because we are going to be spawning it later with the instantiate function. Let's now create a base script for all the weapons to inherit from. If this is your first time working with inheritance or hearing of inheritance, I'll give you a basic rundown on what exactly it is. In essence, C#, the programming language that Unity supports, allows classes to inherit from one another. When a child class inherits from a parent class, it pretty much just gains the features of the class it inherits from. This is extremely useful for us because it helps us in reducing the amount of repetitive code that we have to write for specific weapons. We want a script that controls all the base features of a weapon, then a specific script for the weapon we are trying to create that expands upon the script with their own individual features. But before we create the script, let's start dividing our scripts into different subfolders as it is getting quite crowded. I created two new subfolders called player and map and dragged the scripts into their respective folders. With that said, create another subfolder called weapons and a script called weapon controller and open it up. Let's create some variables corresponding to the weapon stats. First up is going to be a public game object called prefab to store the weapon prefab. Then will be a public float called damage and a public float called speed to store the base damage and base speed of the weapon respectively. Then will be a public float called cooldown duration to store the cooldown duration of the weapon. Then will be a float called current cooldown to store the current cooldown duration of the weapon. And last but not least will be a public integer called pierce to store the base pierce of the weapon. If you don't know what pierce is basically the maximum amount of time a weapon can hit an enemy before it gets destroyed. We won't use this for now, but it will come in handy later in the future, so we just leave it here. Now, in the start function, set the current cooldown to be the cooldown duration, and doing this will basically just ensure that the weapon starts with the intended cooldown. So what that means is that if the player gets the weapon, it doesn't just shoot immediately or activate the weapon immediately. It actually has to wait for the cooldown. Then, in our update function, all we want to do is just continuously reduce the current cooldown until it reaches 0 and then attack. Create a new function called attack, and within it, set the current cooldown to be cooldown duration once again. This is because if the function runs, it means that the player has attacked and the weapon cooldown should be reset, thus creating an infinite loop. Alright, great. Now we have the basic features of a weapon setup. This parent class will make sure that the projectile is fired at the correct time after the cooldown is over and also reset the cooldown as well. Head back into your editor and under the player object, create a new empty game object called knife controller. Make sure its transform is reset. Next up, let's create a new script called knife controller and add it into the knife controller object. Now, inside the script, we are going to want to change the derived class from mono behavior to weapon controller. This way, our knife controller script has access to all the features of the weapon base script. Now, let's override the three functions of the parent class. Overriding is essentially just changing the parent class function in a child class, such that when we call the function, the newest or most recent function is called. For instance, if I have a function called attack in the parent class, and if I have the same exact function with the same name in the child class, the one in the child class will be the one that is called. This is extremely useful because it helps us to use slightly different functions unique to the weapon itself while keeping the base features intact. To do so, head on over to the weapon controller and let's apply the virtual keyword to all functions. So what this keyword does is basically it just tells the function that we're trying to override it in a child class. And without this keyword, you will get a warning when you try to override. You should then see an error just telling you that the virtual functions cannot be private, so let's just set them to be protected. So by now you should already know what public and private are, and you can think of protected as the combination of the two. The protected keyword allows us to access all the features of the parent class inside the child class, just like public, but they will not be accessible outside the child class, just like private. Meaning you will not be able to call any of these functions outside of a child class, but inside a child class, it is just free reign. Inside the knife controller script, you should just see some green squiggly lines under the start and update functions. Delete the update function because we're not going to modify it for the knife, and then create a new function called attack as we want to modify the attack function later on in the future. To fix these warnings, just add a protected and override keyword similar to how we did so for the weapon controller. Next, we have to call the original of the overridden function within itself using the base call functions. So yeah, just do base.start and base.attack. Secondly, we want to spawn the prefab of the knife as an object called spawnKnife using instantiate, and set the spawn knife's position to be the exact same as the knife controller object that is parented to the player. That way, we know that the knife will always spawn at the player's position and not some wacky position. Now we'll leave this script be for now and come back to it later. And if you head back into the editor, you will see that the knife controller script has all the parameters of the weapon controller script. Up next, we're going to want to create a base script for projectile weapon behaviors, similar to how we did so for the weapon controllers. However, this script is not to be confused with the weapon controllers. It is meant to be the parent script of the script put on the instantiated prefab, since it is much easier to define movement and other types of behaviors if it is placed on the game object itself. With that said, create a new script called projectile weapon behavior. Inside here, we want to create a few things. First up will be a protected vector 3 called direction, which will be used to track the direction that the weapon should face. Afterwards, the second will be a public float called destroy after seconds, used to destroy the object after a set amount of time has passed. Then, we need a public function called direction checker, used to check the direction the weapon should face and set it. We need the direction checker function to be public because we'll be calling it in several scripts later on. Now, in the start function, set the object to destroy after the destroy after seconds variable, and then inside the direction checker, create an argument with the type vector3 and name it dir. Simply set the direction variable to have the same value as the argument, so this will also come in handy later on. We should also set the start function to be protected virtual so that we can utilize overrides in child classes later on. Now, let's add a script for our knife projectile called knife behavior and place it on the knife prefab. In here, let's do a couple of things. Set the parent class to be projectile weapon behavior, and then set the start function to be a protected override and call the base function within it. Inside the update function, set the position of the object to constantly move by multiplying the direction with the set speed and time. Head back into the editor and set the destroy after seconds on the knife behavior on the knife prefab to be something like 3, and drag the prefab into the knife controller parameter and cooldown duration. If you now hit play, you'll see that nothing really happens except for the knife spawning on top of the play object and getting destroyed shortly after. This is because we haven't yet set the direction in which is used to define the movement of the knife. Now within the knife controller script, right after the spawn knife's position has been set, we need to reference the direction checker and set the parameter of our movement vector in our player movement script. To do so, we must first reference the player movement within the base class of the weapon controller, such that future child classes also have access to it. Afterwards, all we have to do is to now call the function by referencing the knife behavior script on the projectile. Head back into the editor afterwards and set the speed. I'll set mine to be 10 respectively. Now, when you hit play and begin moving around, you should see that the knife flies in the direction the player walks. Awesome! However, as you might have been able to tell already, there are several issues with what we currently have. First off, the direction in which the knife is facing is completely wrong and isn't even rotated properly. Secondly, the spawn knife doesn't save the last direction in which the player was facing and thus doesn't move if the player stands still. Now this is because we are referencing the move vector, which can be 0 if you remember from the first part. Now we should begin with the first issue. So let's open up our knife prefab in the editor and set it to have a rotation on the z-axis to be -45, such that it is pointing towards the right. Now this way we'll be able to work with a knife facing a cardinal direction, in this case is right, instead of one that is diagonal. This will help us in determining our scale and rotation to change later on to face the different directions. Now remember the direction tracker function that we created in the projectile weapon behavior script? Well, now it's time for us to expand on it. Let's create two new local floats called dir_x and dir_y and set them to be the direction values of their respective axes. Now, let's create two more local vector 3s called scale and rotation and set them to be the local scale and rotation.euler angles respectively. Now, let's use these to fix the orientation. Since we changed the default state of the knife to face right, we can start with the left. Currently, if you move left and wait for the knife to shoot and pause the editor, you can see that the knife faces the right instead of the left. To fix this, we just have to figure out what sort of scale the knife needs to face the left. Look towards the transform component of the knife and change the scale of the x and y axis to be -1. Now the knife should be facing left. Great. Now that we know what has to be changed, let's head back into the script and start creating an if statement. Since this is only for the left, the conditions must naturally just check if the x-axis is below 0 and the y-axis is, well, 0. Now inside, we just have to set the scale of the x and y axes to be equal to their current scale multiplied by -1. This will give us our desired result. Okay, so the last thing we have to do is just set the local scale to be scale that we just defined all the way at the bottom of the function. And let's also set the rotation so that we don't forget it later. Now take note, for the rotation, you have to use the quaternion.euler function because you can't just convert a quaternion to a vector 3. Now when you play the game and move left, the knife should now be facing in the correct direction. Awesome. However, as you might have guessed, this is where the tedious part begins. Similar to how we made the reference to the static points in the last part, we now have to do the same for each of these directions the projectile can face. And as I've said before, since the default state of the knife has been set to right, only left, up, down, right down, left up, and left down are needed. Head back into the editor to do some trial and error for each of these directions mentioned. Some of them may only need a change of scale or rotation, while others might need both. Now please note, if you are using a different weapon sprite from mine that has a different starting rotation, you may need to do some more trial and error to get the correct results, so please don't blindly follow along if that's the case. And once all is said and done, you should have something like this. Now back in the editor, hit play, and you should now see that no matter which direction you move, the knife will naturally have the correct direction. Now comes the second issue, which is the knife doesn't move when the player is standing still. To fix this, we just have to have a clear understanding of what we are trying to achieve. In Vampire Survivors, when the player stands still, the knife shoots at the last cardinal direction, which is right, left, up or down, that the player faces. Which means that in this case, we just need to find a way to track which direction came last. And if you recall previously, we already have something similar that we created in the first part, which is the last horizontal vector and the last vertical vector, used to determine the last values of their respective axes. We just have to track which of these two was set later, if that makes sense. Open up your player movement script, and once inside, we just have to create a public vector2 called last moved vector, and let's also add a hide in inspector attribute to it. Now within input management, all we have to do is set the last move vector under the setting of the last horizontal vector and last vertical vector. Now create a new if statement checking if both the move their values are not 0, and if they aren't, set the last move vector to have the values of both the last horizontal vector and last vertical vector. Now, this is to check for when the player is moving on both the x and y axes to make sure that we aren't storing the values that allows the player to shoot diagonally when they stand still. Because if both the values are not 0, this will result in a diagonal direction, meaning that the knife will fly diagonally when the player stands still, which is not what we want. Last but not least, in the start function, we just have to set the last move vector to be 1 and 0f, because if we don't do this, the knife will not move if the player doesn't move first. We essentially need to set the default direction of where to shoot the projectile, and since we set the default direction of the prefab to really face the right, we just set the last move vector to be the right as well, so that we give it the same movement. Now in the knife controller, pass in pm.lastMoveVector. Alright, now your projectile should be firing based on the most recent direction even while standing still. Let's start creating our first melee weapon. For this, we're going to be replicating the garlic from Vampire Survivors that creates a ring around the player and damages enemies within it. Create a new empty game object called garlic controller and place it under the player. Then create a new script called garlic controller and add it to the game object. Before we move on, let's also organize the weapon subfolder in the script subfolder for better clarity. We'll create 3 new subfolders called weapon controllers, weapon behaviors, and weapon base. Drag and drop the respective scripts into their folders and open our newly made garlic controller script. Inside here, we are just going to want to do something similar as for what we did in the knife controller script. All we have to do is just set the parent class to be weapon controller, and now remove the update function and set the start and attack functions to be override and call their bases. Now we have to set the position of the spawn prefab to be the same as the players and change their parent to be the player as well, such that when it spawns, it will follow the player around. Create a new C# script called melee weapon behavior and open it up. Just like the projectile weapon behavior, let's give it a time to destroy itself. Now create a new script called garlic behavior, and all we have to do in this script is to set the parent class to be melee weapon behavior and override the start function. Alright, now that we're done, head back into the editor, and inside our weapon sprite sheet, choose a shield sprite to drag and drop into the scene view, because the shield sprite looks more like, rounded, and the garlic's effect is rounded. So I'll be using the weapon sprite sheet _33 as it seems the most rounded and I just like the look of it. Reset its transform and rename it to garlic weapon. Size it to be a bit bigger than the player, so I'll size mine to have a 2 scale across all axes because we want it to encapsulate the player. Now before we move on, there's just one issue. As you can see, the sprite is actually above the player, so this is the perfect time to sort our sorting layers before it gets too messy in the future. Click on the sorting layer drop down under additional settings of the sprite renderer component and hit sorting layer. Our goal for this is to add different sorting layers such that objects don't overlap one another. With that said, let's create 3 different layers called background, midground, and foreground and arrange them like so. That way, foreground will always appear before everything else, and midground will always appear before background, and default, and so on and so forth. Now, change the sorting layer of the player and garlic weapon to be foreground. Now, change the player's order in layer to be something like 20, just to make sure that it appears over everything else. Now your weapon should appear behind the player. That's good. Let's do the same for the other prefabs as well, but before that, make the garlic weapon a prefab and remove it from the scene in case we forget. Afterwards, let's change the knife weapon to be foreground, and then we can change all props to be midground and change all the terrain chunks background tile maps to be background because they're always going to be at the back. Drag and drop the garlic behavior script onto the prefab and set the destroy after seconds parameter to be something like 2. Add the relevant parameters onto the garlic controller script, and the only thing we really have to define is the prefab and cooldown duration for now, so I'll just set the cooldown duration to be 3. Now if you hit play, you can see that the garlic spawns and follows you around and also destroys itself afterwards. Awesome! We've come to the last section of part 3, which is creating basic enemy AI. For our first enemy, let's go with the bat as it is the first enemy one will encounter when first starting out Vampire Survivors. We'll be using this pixel bat sprite sheet that I found on opengameart.org for the asset of the bat. Now drag and drop it into the art folder and rename it to bat sprite sheet. Make sure to slice it afterwards using the automatic preset. Now, simply multi-select the bat sprite sheets 1 to 3 of the sprite sheet and then drag and drop it into the scene. Now this should open up your Explorer as a prompt to create an animation. Just need to navigate to your animations folder and rename it to bat move before clicking save. Now make sure to set the sorting layer of the newly created bat object to be foreground and rename it to bat. When you play the game, you can now see that the bat has animation. Great! But before we move on, let's add a box collider 2D for future use as well. Then we just need to reset the transform and then create a new subfolder under prefabs called enemies and make it a prefab. You can leave the existing object on the scene as we use it as a sample later on. Now on to enemy movement. In Vampire Survivors, the enemy AI is very simple to understand as it simply just follows the player around. There are many different ways of doing this in Unity, but I'll be using the simplest method, which is basically just moving the enemy towards the player using the vector2.move towards function. Start by creating a subfolder called enemy inside scripts and then enemy movement inside of the folder. And inside here, we really only need to do 3 things. Just create a reference to the player's transform, then a public float called move speed to define the speed of the enemy, and then we just need to move the position of the enemy to be the position of the player. Now back in the editor, make sure to add the script onto the enemy prefab and set the speed to be something like 2. Now when you play, the enemy should be moving towards the player no matter which direction you go. Great! That's all for this part. In this part, we went through how to create our first weapons and basic enemy AI. If you are a Patreon supporter, you can also download the project files for what we've done so far in the description below. So that's all, and I'll see you guys in the next part. Bye!